in this question of problem set, you are asked to plot indifference curves or indifference map to say. And let's take what the question is all about. The question is that Richard enjoys mocha swirl ice cream X, but he hates mushroom. So you're asked to plot the indifference map of Richard for these two goods. Now, just see this. Let's first think in terms of utility. Then I will think in terms of the diagram also. Okay. So in terms of utility, supposedly I give Richard one ice cream and one mushroom. Just keep thinking, okay? And suppose Richard gets certain level of utility from it. Now I ask you, what happens if I hold ice cream constant, but I increase mushrooms? Supposedly, I give you another bundle where I still give Richard one ice cream, but I give Richard two mushrooms. Then what happens to the utility? Well, because mushroom is related to decrease in utility. He hates mushroom. So, you know, what happens in this case is something like this, that the utility from this will be lesser than the utility from 1, 1. Do you agree? As I increase mushrooms, utility decreases. This makes sense? Now let's ask, what happens if you instead increase ice cream and keep mushroom constant? So I hold mushroom constant and I increase ice cream. So utility from one ice cream, one mushroom, and utility from two ice creams, one mushroom. Definitely this is more. The more the ice creams, the more the utility. This is also fine. Now I ask you how to hold utility constant. You know, when I increase ice cream and hold mushroom constant, utility increases. Because more ice cream, more the utility. When I increase mushroom, hold ice cream constant, utility decreases. Because more the mushrooms, lesser is my utility. But when I increase ice cream and increase mushroom at the same time, then increasing ice cream would increase utility. Increasing mushrooms will decrease utility because mushroom is something he hates. And the two may nullify each other, holding utility constant. Isn't that the case? If this is the case and I ask you how to plot this around, then you can say something like this. So this is, I'm taking on x-axis, I'm taking ice creams. On y-axis, I'm taking mushrooms. One ice cream and one mushroom give me some level of utility. Just keep thinking. If you increase ice cream and you keep my mushroom constant, then B has higher utility than A. Okay. If you increase mushrooms but keep ice cream constant, a point like C, C has lower utility than A. So utility from C is lesser than utility from A. Isn't that the case? So from transitivity, if I have to combine these two things together, and if I combine these two things together, what will I get? That utility from A will be less than utility from B, will be greater than utility from C. What happens if I increase ice cream and mushrooms together? Look, then increasing ice cream will increase utility, increasing mushroom will decrease utility, and overall it will be same as A. So maybe a point like D, where both mushroom and ice cream increase, has maybe, my D could have been here, but utility from A may be equal to utility from D. If I join these 2 points because they have the same utility, I get an indifference curve. So this is indifference curve, because A and D have the same level of utility. D has more ice cream increasing utility, more mushroom decreasing utility, and hence keeping utility constant. Similarly for B, I can have another indifference curve passing through B. I can have another indifference curve passing through C. And now if I ask you what is the direction of preferences, you will tell me that the direction of preferences is that I know B is preferred over A is preferred over C. So my direction of preferences is this. IC2 is preferred over IC1 is preferred over IC0. Is this fine? If you understand this, and I ask you, give me a classic example of utility function, any utility function. So your utility function can look like this. Now, just look, my indifference curves are upward sloping, right? So I just have to draw any curve which is upward sloping. Any equation that represents a line which is upward sloping, and x minus y represents a line which is upward sloping. Isn't that the case? Just take utility constant at, let's say, 10. So when I say x minus y is equal to 10, I know x is equal to 10 plus y. Isn't that the case? Isn't this an upward sloping indifference curve? It is, right? How do I know this, that this is an upward sloping indifference curve? Put y to be 0. X is 10. Put y to be 1. X is 11. Put y to be 2. X is 12. I get a curve like this. And then, all other curves can just represent curves like this. And this is exactly the curve that I have drawn. So in an equation like x minus y is an upward sloping equation. Upward sloping line. Similarly, if I ask you, how do you represent lines like this, which is nothing but a perfect substitute case? You say my utility function looks like this. If your utility function is like this, it is a downward sloping line, right? Isn't that the case? So this completes our analysis.